Good morning again, grade 8 students. This is me, Teacher Christine, welcoming you all to another lesson for this week. So before we proceed with our new lesson, let's have first a short review on what we have discussed last week. Last time, you were able to learn about electromagnetic spectrum. And you were able to learn that all electromagnetic waves travel at the same speed in a vacuum, but they have different wavelengths and different frequencies. You were able to learn also that the electromagnetic spectrum is made up of radio waves, microwaves, infrared rays, visible light, ultraviolet rays, X-rays, and lastly, the gamma rays. So our lesson for this week is Lesson 3 of Chapter 9 entitled Wireless Communication. At the end of the lesson, you have to know the following objectives. First, explain how radio waves transmit information. Next, explain how cell phone works. And lastly, explain how communication satellites work. And these are the vocabulary words that you have to know at the end of the lesson. The first one is amplitude modulation, and the next one is frequency modulation. So before we proceed with our new lesson, I want you to prepare the following materials with you. First, you have your textbook. The next one, you have your pen. And lastly, your highlighter. So to begin our lesson, I would like you to open your textbook on page 308, and I want you to read the passage entitled Teens and Their Cell Phones. Afterwards, I want you to answer the questions that follow. Nowadays, we can say that a cell phone is already a necessity for everyone. And as a teenager, you have to be responsible enough when you are using your cell phones. So, why can having a cell phone make someone feel safe? Of course, you could call your parents for a ride if you are lost or if you missed a bus, or you could call the police if you witness an accident. How do radio waves transmit information? Imagine yourself that you are in a car on a long road trip and switch on the radio to listen to some music. In an instant, your favorite song is coming through the car's speakers. How do radio broadcasts reach you? The answer is simply broadcasting. Radio waves carry or transmit signals for radio programs. Charged particles vibrating inside transmission antennas produce radio waves. Transmission antennas send out or broadcast radio waves in many directions. Radio waves carry information from the antenna of a broadcasting station to the receiving antenna of your radio, as shown in this picture. In the following pictures, you will see the correct sequence of events that results in hearing a broadcast. First, at the radio station, electronics convert music into radio waves that are then broadcast by a large antenna. And then, radio waves strike your radio's antenna and are picked up. Third, in the interior of the radio waves are converted into an electronic signal. And lastly, the electronic signal comes out of your radio as a sound. So before we proceed with the next concept of the lesson, where are the antennas for radio broadcasting located? They are located on broadcasting station and on your radios. So now we will proceed with page 310 of your textbook, Broadcasting Signals. Radio stations broadcast signals in two frequency bands. These bands are amplitude modulation, or AM, and the second one is frequency modulation or FM. So we will first discuss the amplitude modulation or AM. This is a method of broadcasting signals by changing the amplitude of a wave. AM signals travel as changes or modulation in the amplitude of the wave. The frequency of an AM wave is constant. AM radio waves have relatively long wavelengths and low frequencies and energy. They are easily reflected back to Earth's surface by ionosphere. What is an ionosphere? It is simply a region of charged particles high in the atmosphere. Therefore, AM radio stations can be broadcast over long distances. So now we will proceed with the second frequency band, and it is called frequency modulation or FM. It is a method of broadcasting signals by changing the frequency of a wave. FM signals travel as changes in the frequency of the wave. The amplitude of an FM wave is constant. FM waves have higher frequencies and more energy than AM waves. FM waves pass through the ionosphere instead of being reflected back to Earth. Therefore, they do not travel as far on Earth's surface as AM waves. However, FM waves usually produce better sound quality than AM waves. So I want you to take note of what is being kept constant in the two frequency bands. So for AM waves, frequency is the one that is being constant, while in FM waves, the amplitude is the one that is being constant. So to compare and contrast the two frequency bands, let's start off first with AM waves. In AM waves, the amplitude changes and the frequency is being constant. AM waves have lower frequencies and less energy compared to FM waves, and they do not pass through the Earth's ionosphere. On the other hand, the FM waves, the amplitude is being kept constant, while the frequency is the one that is changing. FM waves have higher frequencies and more energy compared to that of AM waves. They pass through the Earth's ionosphere, and both of them are methods of transmitting signals for radio broadcasts. So the next one that we have to discuss is about the radio spectrum. In addition to AM and FM broadcasts, radio waves are used for many types of communication. The FCC assigns different radio frequencies for different uses. Radio stations use one part of the radio spectrum. Taxi and police radios are assigned separate sets of frequencies. Amateur radio frequencies are assigned for people who operate radios as a hobby. Because the signals all have different assigned frequencies, they travel without interfering. So please take note the following, and you have to know it. KHZ represents kilohertz or 1000 hertz, and that MHZ represents megahertz or 1 million hertz. So if I'm going to ask you what frequency is greater, is it 54 megahertz or 1605 kilohertz? So the answer would be 54 megahertz. So the next thing that we have to discuss is how does a cell phone work? Cellular telephones or cell phones are an important part of your daily life, of course. However, they only work if they are in a cellular system. The cellular system works by dividing regions into many small cells or geographical areas as shown in this figure. Each cell has one or more towers that relay signals to a central hub. Cell phones transmit and receive signals using high-frequency microwaves. Though the process needed to complete a cell phone call looks complicated, the entire process happens so quickly. It seems to be instantaneous. In addition to making phone calls, cell phones have many different uses, such as they can be used to send text messages, browse the internet, and take photos. So in this figure, you will see how does a cell phone work. First, when you place a cell phone call, the phone sends out microwaves, which are tagged with a number unique to your phone. That's why you have your own phone number. And then, a tower picks up the microwaves and transfers the signal to a hub. Third, the hub channels and transmits the signal to a receiver. The receiver may be another tower or another hub, depending on the distance between the two phones. Fourth, the tower or hub transmits the signal to the receiving cell phone. And lastly, the receiving phone rings when it picks up the signal. You can see that the process is complicated, but it happens very fast. Next, we have to discuss about how does satellite communication work. Satellites orbiting Earth send information around the world. Communication satellites work like the receivers and transmitters of cellular phone system. Communication satellites receive radio, television, and telephone signals and relay the signals to receivers on Earth. Because a satellite can see only part of Earth at any time, more than one satellite is needed for any purpose. So please take note, communication satellites receive radio, television, and telephone signals and relay the signals to receivers on Earth. Satellite phone systems. Several companies offer satellite phone systems. Radio waves from one phone are sent up to a communication satellite. The satellite transmits the waves back to the receiving phone on Earth. With this kind of phone, you can call anywhere in the world, but it costs more than using a cell phone. The next one is satellite television systems. Television network and cable companies use communication satellites, just like OSN. Television signals are sent up to satellites. The satellites then relay the signals to places around the world. Television signals from satellites are often scrambled. Customers of satellite companies need a satellite dish, antenna like the one in this figure, to pick up the signals and a decoding box to unscramble the signals. The last one is Global Positioning System. The Global Positioning System, or GPS, is a system of navigation originally designed for the military. GPS uses a network of 24 satellites that broadcast radio signals to Earth. These signals carry information that tells you your exact location on Earth's surface, or even in the air. Anybody with a GPS receiver can pick up these signals. GPS receivers can be found in cars, airplanes, boats, or even in your cell phones. Signals from 4 out of 24 GPS satellites are used to determine your position. The signals from 3 satellites tell you where you are on Earth's surface. The signal from the 4th satellite tells you how far above Earth's surface you are. So to wrap up everything in this lesson, first, radio waves carry information from the antenna of a broadcasting station to the receiving antenna of a radio. Next, cell phones transmit and receive signals using high-frequency microwaves. And lastly, communication satellites receive radio, television, and telephone signals and relay the signals to receivers on Earth. Thank you so much. That's it for today. Wait for another video for a new lesson. Again, Thank you so much.